Welcome to A+ Economics, your guide to an A+. Today we are diving into an essential concept in statistics, measures of dispersion. In our previous episodes, we learned about measures of central tendency like mean, median, and mode. Now, it's time to understand how spread out our data is. Buckle up, as we explore measures of dispersion.
To begin, let's recall that statistics is all about summarizing and analyzing data. While measures of central tendency give us an idea of the typical value, measures of dispersion quantify how much our data varies from that typical value. First up, we have the range. The range is defined as the difference between the largest and the smallest value in the data set. For example, if we have the following data set, 5, 17, 45, 78, 99. Notice that the largest value in the dataset is 99 and the smallest value is 5. The range is equal to 99 minus 5, which is 94. Now, let's switch gears to the interquartile range, or IQR, which measures the spread of data around the median. To find the IQR, we first calculate the median of our dataset. Then, we find the median of the lower half of the data and the median of the upper half. The difference between these two medians gives us the IQR. Consider the following example. The data 5, 17, 23, 45, 78, 99, 101. The lower half of the data is 5, 17, and 23. The upper half of the data is 78, 99, and 101. The median of the lower half is 17 and the median of the upper half is 101. The IQR is 101 minus 17. That is 84. Next up, we have the variance. It's a widely used measure of dispersion. Mathematically, it's the average of the squared differences between each data point and the mean. But hang on, that formula can be a bit daunting. Let's look at a simpler way to understand it. Imagine we have some data points, 5, 6, 7, 8, and 9, the mean of this dataset is 7. Now, let's find the differences between each data point and the mean. We get -2, -1, 0, 1, and 2. To get rid of those pesky negatives, we square each difference, 4, 1, 0, 1, and 4. Finally, we take the average of these squared differences, which gives us the variance. Now, while the variance tells us about the spread, it's not in the same units as our original data. That's where the standard deviation swoops in. It's simply the square root of the variance. Now, let's talk about a relative measure of dispersion, the coefficient of variation. It helps us compare the dispersion of different datasets regardless of their scales. Say we have two datasets, one representing the heights of people and another their weights. The heights have a standard deviation of 3, and the weights have a standard deviation of 10. The coefficient of variation for heights would be 3/average height, and for weights, it would be 10/average weight. By doing this, we can compare the relative dispersion of both datasets.
Congratulations! You've now grasped the importance of measures of dispersion in statistics. We covered range, variance, standard deviation, coefficient of variation, and the interquartile range. But remember, different situations might call for different measures of dispersion. That wraps up this episode of our introductory statistics series. If you found this information helpful, don't forget to hit that like button and subscribe to our channel for more statistical adventures. Also, let us know in the comments what other statistical concepts you'd like us to explore in future episodes. Thank you.